When we answer the question, what is statistics, it's important to understand that statistics can either be a noun or a verb. For right now, we're going to use it as a verb. And so we're going to say that statistics is the process of collecting, organizing, and interpreting data to make decisions. Well, basically, statistics help us make sense of numbers. As I just mentioned, statistics is a way to get information from data. Data is just the raw numbers. It doesn't make a lot of sense. So, in this case, we use statistics to give us information. Information is data that makes sense. Here you see some data. Data in this case is just some raw numbers. We don't know anything about these numbers and they don't make a lot of sense. There could be thousands of these numbers. So statistics will help us make information out of these numbers, and we'll see that in the next slide. Well, now we have used statistics to summarize the data, and some of the values and names that you see right now probably don't make a lot of sense if you haven't had a statistics course before yet, but some of these do. Mean, or sometimes we call it the average, the median, the maximum, the minimum, the count, and the sum. So we've used statistics, the process, to summarize the data and describe it in this case. So we have an example here of descriptive statistics. This little diagram kind of explains where we're headed in this course. We're going to start by working with descriptive statistics, and we just saw an example of that where we're going to be working with things like mean and mode and maximum, that sort of thing. But eventually we'll progress into inferential statistics, and inferential statistics are going to help us make decisions. Let's just take a moment here and define descriptive statistics and inferential statistics a little bit more in detail. So descriptive stats is the process of organizing, summarizing, and presenting the data in an informative way. And an example might be the average age of a student at this college is 22.5, or as we saw on the previous slide, things that would include the mean, the mode, and that sort of thing. Inferential statistics is where we're headed towards the second half of the book, but that's the process of making predictions or decisions about a population based on a sample of that population. For example, if I were to survey 100 college students, and I could decide at that point, based on my sample, I would make a decision, maybe on their age, that the average age of the student in general at the whole college might be 23.5. But I've made that inference based on the sample that I've taken, not by surveying every member in the population. All right, just to make sure we understand the difference, the population is all the members of the group. If my population were all the students at this college, that would be the population. The sample would be just some of the members, either taken at random, or there's various ways to sample that we'll learn as we go a little bit further in this class. I've mentioned the word survey already a couple of times, and a survey is going to have variables, and variables are the characteristics that we're looking for, such as age, number of siblings, number of credits taken in a class. So those are all variables that we'll be tracking when we survey a sample. Well, you probably understood we're going to get a little bit more complex as we go, and now we're going to introduce you to the different types of variables. You can see that there's two broad categories, qualitative and quantitative, and then there's some subcategories within that, and we're going to spend just a couple of minutes talking about these different categories. Qualitative variables are variables that are not readily turned into numbers. For instance, gender would be qualitative. Another example of a qualitative variable would be, how do you feel about the college that you attend? Typically, though, is for statistical analysis, where you're going to work with qualitative variables that we can turn into numeric values, such as gender. Okay, we could assign a 0 for male and a 1 for female. So in that case, we can do some statistical analysis for some qualitative variables, but a qualitative variable such as how do you feel, it's hard to do any kind of statistical analysis with that. Most of the time in statistics we'll be dealing with quantitative variables, and quantitative variables are numerical. Now, there are a couple of different categories of quantitative variables, as you can see here on this slide, and we'll talk about that here in a second. But a quantitative variable could be an example of such as the balance in your checking account, how many credits you're taking, how many books you bought this semester. So those would be quantitative variable examples. As you can see, quantitative variables can be broken down into two different categories, discrete and continuous. Discrete essentially are going to be whole numbers, children in a family, TV sets owned. You can't have 1.5 kids. We don't count the ones in the oven at this case. Continuous, on the other hand, can be any value. The weight that an individual has. It could be 1.2 pounds, 1.3 pounds, or the amount of air in a tire, the amount that you paid in income tax. So those things would be continuous variables. And it is important to learn and understand the difference between these. Discrete, again, a whole number; continuous, any value within the range. As you just learned, there are discrete and continuous variables, but there's also 4 different levels of measurement for quantitative variables. They are nominal, interval, ordinal, and ratio. And we'll go ahead and explain those in detail on the next slide. Okay, let's give this a shot. As we see, there are 4 different levels of measurement, and the first is nominal. Nominal is when the data can simply be classified. There isn't an inherent value in there. For instance, if we had a list of 4 makes of car, Ford, Dodge, Toyota, and Honda, and we just assign Ford number 1 and Honda number 4, there isn't an inherent rank in there. With an ordinal value, there is an inherent rank, and so we might say, okay, pick your favorite teams in order of 1 to 10, or the BCS standings, that sort of thing. Interval values are meaningful, where there are meaningful differences between the values, such as temperature. There is a meaningful difference between 20 degrees and 30 degrees. A dress size 2 and a dress size 6, there's a meaningful difference in there. Now, ratio is very similar to interval. The main difference is that a ratio value, that the 0 point really means 0. Temperature, in using the interval, 0 degrees really doesn't mean the absence of temperature. But with a ratio measurement, 0 would mean 0, such as the number of patients seen, 0 means 0. Okay, so those are the 4 levels of measurement for quantitative variables: nominal, ordinal, interval, and ratio. Spend some time, look at the book, and make sure you do understand the difference between these.